right, properties of systems. Now, believe it or not, you actually know everything on this page, but we're going to go through it anyway. Graph this system. I do not care how you graph it. I will be graphing it myself. Some of you will watch me graph it. Some of you will graph it on your own. It is up to you. You choose. I, of course, am going to do what I always do, which is put it into slope-intercept form. Should I graph this line right now? Yes or no? No, why not? I might need to change the scale. Good job. So, do I need to change the scale? Yeah, but we should avoid doing that, right? So, well, let's just wait a sec. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? I should be right there, shouldn't I? But that's off the graph. But I know the slope is -2, don't I? So if I go down 2 and right 1, now I'm on the graph, aren't I? Everybody understand? Okay. Down 2, left 1, or down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1, and so on. I'm not going to connect the line because obviously, since this is a sample, it's going to work out perfectly, right? So I only need the dots. The blue one goes to where? 1, 2, 3, 4, 5, 6, and it's got a slope of -3/4. Down 3, right 4. And there is the answer. And the answer is what? 4, 3 is my answer. Everybody cool? Now, conclusions. What do we know about this system? Now I'm going to connect the line. There's the red line. Oops, that's not the right blue. There's the blue line. What do we know about this system? It's made up of what? It's a pretty tough question. It's made up of X's and Y's. Excellent. Good point. And when I take those X's and Y's and turn them into a picture, what do I get, Evan? I get a graph. And on that graph is points that make what? No. The points don't make an equation. What do the points make? What did this bunch of red points make? A line. What did this bunch of blue points make? A line. Excellent. So I got 2 lines, yes? What do we know about those 2 lines? Where is this red line going to go? Up. For how long? Forever and ever and ever. Where is it going to go here? Down. Forever and ever and ever. Is it ever going to turn? No. What about this blue line? Where's it going to go? Forever and ever and ever. What about this way? Forever and ever and ever. Is it ever going to turn? No. So how many times can lines cross? Once and once only, correct? What is it about these 2 equations that prove to you that the lines have to cross? They're not the same slope. So at some point they are going to cross over. Does everybody understand? They have to. Right? But even if they weren't one pot, they're both negative, but because they're not the same, they are going to cross somewhere in the universe. Agreed? That is the conclusion, which I will continue to write in purple because that is the mix of blue and red. if two lines have different slopes, they'll cross how many times? How many times will they cross? Once. They will cross once, which means there is one solution to their system, because there is only one point in the whole universe that is on both lines. Does everyone understand that? Everyone is good? All right. Next question. Easy peasy lemon squeezy. Graph this one. And as usual, we will graph in red and blue. This guy. 4y equals negative 2x plus 12. Y equals negative 2/3 x plus 3. Blue line. 2y equals... No, not 2/3, dummy. 1/2. 2 divided by 4, not 2 divided by 6. There we go. Negative 1/2. And then in blue, 2y equals negative x minus 12. Y equals negative 1/2 x minus 6. Then I graph them. 1, 2, 3. Down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. And I get that line, yeah? Blue one starts at negative 6. 1, 2, 3, 4, 5, 6. Down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. And I get that line. What's going to happen? Where's this line going to go? Forever in this direction, yes? It's going to go down 1 over 2, down 1 over 2, isn't it? Where's this line going to go? Down 1 over 2, down 1 over 2. For how long? If it's going down and over the same amount, what is it? It's the same. It's parallel. Do parallel lines ever touch? No. So what's our conclusion? Read the first conclusion. If two lines have different slopes, they'll cross once. What's the conclusion here? If two lines have the same slope, then what will happen? They won't cross. So how many solutions? 0, because they won't cross. There will be no point in the universe that is on both lines because the lines will never touch. Everybody good? Great. Turn the page over. Look at these two lines. Let's work with them. 3y equals negative 2x plus 5. Y equals negative 2/3 x plus 5/3. Agreed? Agreed? Y is already almost isolated, so y equals here negative 4/6 x plus plus 10/6, which is, what do you notice about that line and that line? They are the exact same line, aren't they? Because this is negative 2/3, isn't it? And this is 5/3, isn't it? So if I were to graph the red line, And we are going to graph it for practice because it's got a fraction. What would I do to my scales to graph that red line? What should I make each square? A third. So 1, 2, 3. There is 1. I need to go up to 5/3. So where do I go? Up 5. 1, 2, 3, 4, 5. If I keep this the same, then am I allowed to just count? If these are the same units? Yes. Down 2, out 3, correct? And the red line would be down 2, out 3, down 2, out 3. It would be that line, right? Which is going to show up in a second. Everyone agree? Yeah. The blue line would be the exact same thing. Up to 5/3 and then every point. And then if I connect that blue line, it's going to be right here, isn't it? How many times do those lines touch?
Infinite.
They're right on top of each other, right? So how many points are my arms touching? All the way along, right? And if it's all the way along and both lines go till infinity, how many times are they going to touch? Forever. So, what's our conclusion? If the equations are the same, the lines touch everywhere, which means how many solutions? Infinite. Pardon?
Contained infinite. It's infinite, and yet it's contained within just a single line.
Oh, you crazy. Whew! Time for you to take a trip to some temple somewhere and open your mind.
I was thinking more along the lines of like just hang off tree branches so the blood will hit my head.
Sure. So, when we graph them, it's super easy to see, right? As soon as you put them on a graph, it's super easy. Oh, the lines cross. There's one solution. Oh, the lines are parallel. Oh, there's no solution. Oh, the lines are right on top of each other. There's infinite solutions. What is the hint that tells you this without graphing? What feature of all of these equations is it that lets you know if there is going to be 1, 0, or infinite solutions? Slope and y-intercept. If the slopes are different, how many solutions? 3 choices here, people. 1, 0, or infinite. If the slopes are different, how many solutions? 1, because the lines will have to cross once. If the slopes are the same, how many solutions? 0, because they are parallel, they will never cross. If the slope and the y-intercepts are the same, how many solutions? Infinite. Great. Go. Tell me if it is 0, 1, or infinite. But you are not allowed to use substitution, elimination, or graphing. So what are you going to do? You can convert it, of course you can. You're just not allowed to solve it. I don't want the answer. I just want to know how many answers there could be. Which proves to me, if you can do it, that you actually understand the concept, the last concept of slope. You already know that it's rate of change. You already know that it's rise of run. You already know that it's y2 minus y1. You already know that it's the change in independent variable divided by the change in independent variable. You already know it's the change in y divided by the change in x. This is the very last property of slope that you need. Is everybody done yet?
Some people are still figuring it out.
Of course, all the work has been recorded on the screen. If any of you choose to watch the video, I'll show the right answers in a moment. Everybody should have at least one, if not all three done. The problem, of course, is C, because it is not an X and Y. Does it matter which one you solve for? No. If you make P X and solve for Q, you're going to get one answer. If you make QX and solve for P, you're going to get one answer, but they're still going to be in slope-intercept form, yes? Okay. So, how many solutions for A? One. How did you know? You did the work and you found that they had different slopes. How many solutions for B? Infinite. Why? Because they're the exact same line once you reduce the fractions. So how many slopes for C? How many solutions for C? Zero, because they had the same slope, but not the same lines, that a different y-intercept. Is everybody good? Now, of course, like I said, if you put P by itself, you would have gotten different equations, but you would have found that the Q's were the same and the constants were the same. Everybody cool? Once, twice, thrice? Okay. Now, like I said, we're ending this unit with some practical uses of systems. Okay? A way that they can actually be used to do some good. So if you could turn the page over to 244, that would be lovely. I think there's some work that goes with 244. Yeah, there is, but it's not much. Okay, again, like we have done for the previous two lessons, read those first three statements. And again, remember, I'm not asking you to do it yet. I just want you to make sure you know what all those words mean. So read those steps for a second while we get situated. Now, I have learned many times that a great many of you have been taught a great many different methods of solving these two different number questions. I learned this the hard way because I was only taught one method to solve these when I was your age. So I was caught by surprise when I was teaching this the first time in the current situation where kids had a bunch of different ways to solve this. And I applaud that. I'm glad that you have those bunch of different ways. But the problem with that is those bunch of different ways are great for two number questions. But they're not so great for other systems questions. Do you understand what I'm saying? So I'm going to show you the way I was taught to do this that will work for every system. Do you understand? If you have your own method of solving these that is different from what I'm about to show you, that's cool. You're welcome to use it anytime you have two unknown number questions. Okay? All right, so let's do this very first step. What are we looking for? And this is key. Right-let statements. We're going to talk about what that means in a minute. This is not an English class. It is not as essential as you may think to write this out. But at the very least, you must think about it. And we're going to talk about that in a moment. So the first thing we need to do is identify what we are looking for. So let's read this question. The sum of two numbers is 176. The difference is 48. Find the numbers. What do I need to find? The numbers. How many numbers, Elijah? Two numbers. Do I know either of them? No. So what do we give in math if we don't know something? We usually give it X and Y, yes? I am not going to use X and Y on this page at all because you know how much it bothers me when kids tell me they can't do math if it's not X and Y. So I'm not going to use X and Y at all. So we know what we're looking for, yes? Okay. We know what we're looking for, right? Two numbers. Now, this right-let statements to identify your variables accordingly. If we were doing this, if you guys had taken a time machine back to 1989, then your teacher, Mr. Voth, Mr. Voth was a cool teacher. He had a glass eye. It was neat. He would never pop it out, which I always wanted him to do. But he had a glass eye, and you could never quite tell if he was looking at you or not, even though you knew which eye was the glass eye, and because it was the one that didn't move. So he would look straight at him, and then this other eye would move over here. And it's hard to do, because I think this eye is looking right at Wong, but this eye is looking at Roberto. I think. It hurts your brain. Anyway, Mr. Voth would make us write these out. Every time. As a matter of fact, Mr. Voth would hand back your test if you didn't write these sentences out. He wouldn't even look at the math. He would just say, and be looking over here with the glass eye and looking down here with the real eye. No, he wasn't really doing that. I like Mr. Voth a lot. He was my second favorite high school math teacher. So, I am not Mr. Voth. I do not care if you write this out. But to do my due diligence, I am going to write it out to show you how much easier it is if you actually do write it out. But again, this is not an English class, so I'm going to kind of meet in the middle. All right? What do I need to find? I need to find number 1 and number 2. Right? I need to find those two numbers. Yeah? So I'm going to assign number 1 the variable of W, as Aiden said, and I'm going to assign number 2 V. And I've done that. So if this was grade 9 for me, I would have written let number 1 be W. And Mr. Voth would have made us write that out. I do not care. This is the same thing. Everybody cool? All right. Does everybody understand what I did for the first step? Yeah? Great. Do that first step for all 4. We'll do it for the first 2. You guys do that first step for number 2. Right now. Just do the first step. Nothing more. Decide what you need to look for and decide what variables you're going to use. Everybody go. I'll wait 30 seconds before I ask my next question. All right. What are the two things I'm looking for in number 2? There's 2 unknowns. What are they? They're costs. Costs of what? Chocolate and pop. So that's the 2 unknown things I'm looking for. And now I need to give them variables. What would be smart letters to use? C and P. Is everybody good with step 1? Yes? Okay. Let's go back up here. Step 2, I'm going to write in blue. Since I have 2 unknowns, I need 2 equations. What if I had 3 unknowns? 3 equations. What if I had 4 unknowns? 4 equations. What if I had 7 unknowns? 7 equations. And we could actually do that, but we're not going to. All right, so step 2 is write 2 equations. This is a hint. Often, every sentence produces an equation. So, is this a sentence? Yep. So that must produce 1 equation. What equation does that give us? No, I need an equation. That gives me W plus V equals 176. Everyone agree? The sum of the numbers is 176. Cool in the gang? All right. Here is a second sentence. So that must give me a second equation. What is it? Not plus. W minus V equals 48. Does everybody see that? Everybody understand? Great. Go to number 2 and do that with the C and the P. There is the first sentence. There is the second sentence. I'll wait 30 seconds whilst you try to figure it out. All right. What is our first equation here? Four C. And our second equation? 2C plus P equals 220. I doubled my plus sign there. While we are waiting for my computer to thaw, what is the last step? Solve the equation, the system, via graphing, elimination, or substitution. Would we ever want to use graphing? No. Why? Why don't we like graphing? It's not exact. So we're going to very rarely use graphing. We're going to use elimination or substitution. We're going to use the one that works better in the situation. Which works better in this situation? Why? Why is elimination the best choice for number 1? What do you notice right there? They're the same letter, and one's positive and one's negative. So if I add them together, it's going to drop out, isn't it? So let's do that. What's W plus W? 2W. What's 176 plus 48? You'll probably need your calculator for that. I'm just going to go ahead and do the math. 224. Then what? Divide by 2, and what's W equal? 112. Now that we know what W is, where can I put it? Anywhere I see a W. Can I put it there? Yep. Can I put it there? Yep. And it will work. So let's do that. 112 plus V equals 176. So V equals 176 minus 112, which is what? 64. 64. So what are my two numbers? 64 and 112. Everybody good? Do that down here. Which method makes more sense here? Substitution or elimination? It's a personal choice, isn't it? Right? I'm very good with both of them, so I choose the one that requires me to do less work from the start. And for me, I see P by itself there, right? So I'm going to do substitution because P is isolated, right? Because P equals $2.20 minus 2C. And now I'm going to substitute. Do you have to do that? No. You could have used elimination, but that would have required you to either multiply this by 2 or 3, correct? If I multiply it by 2, I can eliminate C. If I multiply it by 3, I can eliminate P. Do I care which one you use? No. Do you have to know how to do both? Yes. At least once on your test, I'm going to force you into a choice. But if it ever just says solve the system, which one do you use? Whichever one you like better. Let's be honest, you don't like any of them, but whichever one you're more comfortable with, right? I am going to use substitution. You are welcome to do elimination. Go. I'm going to turn off the screen, but do the work. You attempt it. And when you finish this question, you will see how old this worksheet is.
Yeah, geez.
Wouldn't it be great?
Yeah, that would be amazing.
Has everybody that is going to bother attempting it attempted it? That's fine. You probably had to grab your calculator because of decimals. That's okay, though, because it still works. You can still find these prices when they're on sale.
Severely on sale.
You can often find Big Turks that cheap because they're the grossest chocolate bar ever made. I remember when I was a kid and I tried my first Big Turk, I was like, because I didn't know what any of it was. My mom sent me to the store. Go get yourself a candy bar. Big Turk, that sounds kind of cool. Which bothered me because when I found out what it was, I had read The Lion, the Witch, and the Wardrobe, in which Edmund loves Turkish Delight. But I didn't know what Turkish Delight was because it was, 1982 in Canada. I didn't know what Turkish Delight was. So I got myself a Big Turk, and one bite, straight into the garbage. I didn't even bother trying to give it to my brother. Like, in hindsight, I should have given it to my brother because that would be kind of like torture, right? Oh, this tastes like crap. Try it. In which case, you all try it, which I will never understand. Everybody does that. You take a smell of something. Oh, this stinks like dead anuses. Smell it. And you're like, okay. Oh, yeah, it smells really bad. I don't understand. When someone says that to me, oh, this tastes like crap, I take your word for it. All right. Screen back on, and there's the answer. 65 cents and 90 cents. Did you get that answer if you bothered to try it? If you didn't get that answer, if you did not get that answer, but you did elimination or you did substitution, where is your more likely issue? In your algebra or in your decision to use elimination or substitution? The mistake is in your algebra, yes? Which means if the question were out of on that 4 scale, 1, 2, 3, 4, and you did, most of this right, you're going to get a 2. Okay? You chose a method, you followed it through. Maybe you put a negative in the wrong spot or something. Is everybody good? Okay. Turn the page over. We've got 2 more to try. Let's do the first one together. What are the 2 things I am looking for? You try to sort that out. I'll be writing it in red because I do my first step in red. What are the 2 things that I do not know?
Startup fee and a monthly fee.
Right. I don't know the startup fee, and I don't know the month fee. So since I don't know 2 things, how many variables do I need? 2. What variables should we use? Anything we want. I'm going to use A and B. Why not? Because it doesn't matter. A, B. Everybody happy with that? Great. Now I got to do some equations. So I got to read my sentences. After 1 month, Jen paid $260. So how many startup fees did Jen pay? 1. A. Plus, how many monthly fees did Jen pay? 1, because it was only 1 month. A plus B equals what? 260. After 6 months, she paid $435. How many startup fees did she pay? 1, because it's a startup fee. A. Plus how many monthly fees? 6. I wish I hadn't chosen B now, because 6 and B look a lot alike. But you know what I'm saying.
I chose S.
Sure you did. 6B equals 435. Can I solve that now?
Yep.
Who chooses which one to use? You do. Which one am I going to use because I'm equally proficient at both? I would do substitution. Why, Avery? Because both B and A are isolated. So I'm going to use substitution here. Even though you all know I prefer elimination, but that requires me to multiply this whole thing. And that might be a step that would mess me up. Right? So I'm going to do substitution because this equation lends itself well to substitution. But I just did substitution. Hold up. Could I not eliminate A here? How? What would make A fall out? Addition or subtraction? So I could subtract, couldn't I? So A minus A is 0. It's gone. What's 1B minus 6 B's? Negative 5B. Right? And what's 260 minus 435? You probably got to go to your calculator for that. Is that okay? Of course it is. What is it? Negative 175. How do I solve that? Divide by what kind of 5? Negative 5. So what does B equal? Pardon? 31? No. 35. Right? So once I know B equals 35, where can I put 35? Anywhere I see a letter B. Anywhere. I'm going to put it in this one right here. A plus 35 equals 260. Solve it. A equals 225. What then is my answer? That's not an answer. 225 is a number. Answer the question. There you go. Startup fee is 225. Does everybody understand? Yeah? Okay. Next question. This question, everybody has trouble with this question. Read it. We're going to go step by step. What are the two unknown things? There's two investments, right? And they're both unknown. So I have investment 1 and I have investment 2. Agreed? Let's give it some variables. What do you want to use? A and C? Weird. Okay. A and C. What do I know about A and C? Let's read the sentences. There's the first sentence. What do I know about A and C? Pardon me? A plus C equals what? 2,000. Because he invested $2,000. Some of it in A, some of it in C. Is everybody cool with that? Excellent. What else do we know about A? One of them earned him 8%. Right? How do I write percent as a decimal? 0.08. Right? 8% of A plus, how much did C make him? 0.10 of C made him how much money? 190. Is that a system? Yeah. What about that system bothers you? You don't like the decimals, do you? What can we do to a system to make it have the same answer but look prettier? We can multiply. What would we multiply by to get rid of these decimals? 100. So my second equation is really 8a plus 10c equals what? 19,000. Because 190 times 100. Is everybody cool? And there are my two equations. What way do we want to do this? Which way would I choose? Because I have isolated variables, yes? Which way do you feel as a class you need more practice with? Substitution or elimination? Substitution? Okay. So that means I got to work with which equation? Should I be substituting with equation 1 or equation 2? 1, because it's isolated, right? Does it matter which I isolate, A or C? No. If I isolate A equals 2,000 minus C, correct? What does C equal? 2,000, I heard someone say it, minus A. Does it matter which one I do? No. If I do this first one in green, then that goes in for A, right? If I do the second one, which I'm going to highlight in yellow, it goes in for which? For C. Does it matter which one I do? No. 8A, not A, we're just subbing A, you moron. 2,000 minus C plus 10C equals 19,000. Agreed? Or, if I go the other way, and I'll do both, 8A plus 10 times 2,000 minus A equals 19,000. There they both are. And you know how to solve both of them, don't you? Here you do not need me anymore. Actually, you haven't needed me the whole way, if you stop and think about it. You guys work through whichever one of them you did. I, of course, will work through both, and you will see you get the same answer. Once I get to either side, then I know the other one, don't I? If I did the yellow, one investment is 500. So the other one has to be 1,500, because 500 and 1,500 makes 2,000. If I did the green side, one investment is 15,000, and the other, or 1,500, and the other one has to be 500, because 1,500 plus 500 is 2,000. Is everybody good? It's not hard, is it? Okay. Now let me give you a... Is your hand up or are you stretching? Okay. Let me give you a real-life example of when this could help. Let us say you were trying to choose between, I'll bring it back, Kevin, it's been recorded. You shouldn't need it anyway, we're just doing the algebra. Let's say we're trying to make a decision on two things, yes? That are going to cost us money, right? One thing is going to cost a certain amount of money. So it would give us an equation, right? Like that gym membership one that or the tennis club, right? One tennis club, what was it? It was $220 plus $35 per month, right? That was the first tennis club, yeah?
No, it's 225.
Okay, $225, thank you. Right? Across town, there's another tennis club that charges you $50 per month. How do you decide which one to use? That's where systems would help. Understand? Because if I graphed this, the $50 a month would go up $150, right? And it would make this line. It would go up 50 every month, right? It'll show up in a sec. And then this one starts at $225, but it only goes up $35 every month. See? Where they cross at this point, I'm better to be on the purple line. So if I'm going to be, let's say it's 7. If I'm going to be in the tennis club longer than 7 months, I join the purple line. If I'm going to drop out after 7 months, I go to the drop-in place. Does everybody understand? And believe it or not, you will be forced to make decisions like this all through your life. Right? When you're deciding on what internet provider you are going to have to pay for when you move out eventually. When you were deciding if you're going to have cable TV or satellite TV or no TV or cell phone coverage or insurance coverage or all the millions of things that your mom and dad do for you now that in 5 years, with any luck, you'll be living on your own, you will have to sort out for yourself. And please notice that this little bit of knowledge, how to do a system, can be applied to anything out there. We used this when I worked at 7-Eleven. We used this because it was how we decided how much food to order. Because 7-Elevens are small, right? There's no warehouse in the back like at Save on Foods. So there couldn't be a lot of extra food at a 7-Eleven. So we had to order the right amount of everything. And it was this that we used to decide that. Everybody understand? All right. Not only am I done, you're done. That's grade 10 math. We're finished. Now, allow me a second or two more before I allow you to start working. I know that took till 9:15. I know you've only got 15 minutes to work, but I felt you would rather get the year finished. So, here we are today, June 6th. We need to write a review on this unit. Obviously, we will do that tomorrow because it's a short day. It's only an hour long. Friday is Storm the Wall Day. It's another short day. What? Oh, Storm the Wall starts tomorrow. Right. Thank you. Sorry. Friday is a normal day. So Friday will be a good day to mark our review.
We should probably do the review on Friday, if anything.
No. We're going to start the review tomorrow because you are in class tomorrow. There is class, right? Some of you might be storming said wall, but there is a class. And I don't want to teach anything that day because some people are going to be in and out, right? Also, we have this quiz that I wanted to write, but we took a little longer than I wanted to. So, we're going to storm the wall tomorrow, write our review. Yes. Friday, we'll write our quiz. Make sure you can do it so you have another document that you can keep with you to study from. and we'll mark our review. Monday is first block. You're in here, your write-offs. So I'm not going to test you Monday. The 12th will be your test on systems. Okay? That means we're finished everything new on June 12th. You all will still want a cumulative on the last 3 units because they're all together. I know most of the cumulatives only been on 2 units, but unit 5, 6, and 8 are really the same concepts all the way along, aren't they? So we'll have a cumulative on the 13th, 14th, or 15th, one of those days. All right? I don't want to do it on the 14th because it's a 3-unit cumulative, and the 14th is still going to be a short day. So it's going to be either on the Wednesday or the Friday. All right? Then next week, the 18th is a normal day. You are here 8:30 to 9 or 8:10 to 9:30. Monday is normal. We will use that to go over the cumulative and tie up any loose ends on the last 3 units. Then 19th, 20th, 21st, 22nd are all 4 days that you go to A block on the 19th for the first block. Here. Then you get an X block. I will do before the 19th, I will give you guys a link to a review package that is split into units. You can download as much or as little of that as you feel you need to do. But I'm not going to print an 80-page review package to drop it on your lap and have you do none of it. That's a pain for me, and it's a waste of resources. So I have your review package digital. You can get as much or as little of it as you want. You will know that link long before the 19th. And on the 19th, for that 80 minutes you are here, we'll talk about that review. Okay? Then you have an X block if you wish to come in. I will be here for all of those X blocks. All right? Including Fridays. I know I told you I would be busy Friday, but I've moved what is going to make me busy slightly later in the day. But I will not be here after that X block. Okay? So there will be nobody to borrow a calculator from. There will be nobody to borrow a pencil from. There will be nobody to borrow an eraser from. There will be nobody that can help you with anything that is your responsibility, including how to write that final on the 22nd. You will go to the room. I do not know what room you will be in yet. You will go there. You will write it. The invigilating teacher will bring the exams back to my room, and I will be marking them over the weekend. All right? The vast bulk of the final exam is multiple choice. The vast bulk of it. All right? Any questions for the next few days?
Can you tell me where the unit 5, 6, 7 is?
It starts with the graphing, when you arrived, graphing functions.
Oh, okay. Thanks.
The first thing in it is the dog chart. Everybody cool? All right. You have 12 minutes left in class. I left you with 2 pages of work you could do. Page 243 and page 246 maybe. Yep, page 243 and page 246.
How about 247?
If 246 goes on to 247, then you would do that. Everybody good? Quiz Friday. But the quiz will have no word problems. It's just equations. Go.